All right, we're going to take some quiz today on the beginning of the next chapter. We're moving on in the chapter in our textbook, chapter 3, which covers solving systems. And it covers both systems of equations and systems of inequalities. We're going to focus on the equations for the next few days. First thing I want you to do is to just remember what it means when someone asks you to solve an equation. This is a very simple one from Algebra 1. When you're asked to solve this equation, you're asked to find the value of x, value or values, that makes the equation true. Okay? Now we are solving one equation, and it only contains one variable. It's called solving an equation in one variable. Okay? And y'all know how to do it. Subtract, multiply, divide, whatever is appropriate. And there's my answer, x equals 1. And you also want to remember that step that most of us skip because we like to skip steps, which is checking. Sometimes we do it in our head, sometimes we do it with our calculator. You go back and you check in the original equation. Go back to the very top, so you say 3 times whatever answer you get plus 2, and make sure that it gives you 5. And in this case, we got 1. So you're just double checking that when you plug it back in, that you in fact do get a statement that's true. Most of the time, for Algebra 1 equations, a lot of times they skip that unless it's really hard, and sometimes when they're hard, you use your calculator for it. All right? So that's just a reminder of what it means when someone tells you to solve. All right? When you solve a system of equations, we're going to start with ones that have 2 variables. A system of equation in 2 variables. So instead of just looking for what x is, we're going to be looking for what's x and what is y at the same time. This is an example. I have 2 equations here, and what I want to know is what pair, what combination of x and y will make both the first equation true and the second equation true. Somewhere out there is hopefully a pair of an x and y that will make both of those true. Okay? When we find our solution, remember SOL''N, solution, we're going to have 2 parts to our answer. We're going to get x equals a number, and we're also going to have y equals a number, and quite often we write that as an ordered pair. That's point x comma y. You want to watch out for the order of that. Okay? There are several techniques for solving systems of equations. For our purposes, we're going to do 3 different ones. We're going to learn how to solve with something called substitution. We're going to learn to solve about something, we're going to learn to solve about something called elimination. And then we're going to go back after that and learn how to solve it by graphing. And we're going to do this with and without calculating on the graphing part. We just finished that unit on problem solving and had some graphing in it, so let's take a little bit of a break from that right now. And we're going to go and learn substitution first, as well as elimination. Usually, I find that some students have learned how to do both these things in Algebra 1. Some people have learned how to do one of them, and some people haven't learned how to do either. So I'll give you enough notes if you've never seen it, that you ought to be able to understand it. And if you have seen it, it should remind you of everything that you learned last year. Okay? So we're going to start with substitution. Oh, and I guess I'll just put it out there right now that when we take our first quiz over this, I will specify the process. I want you to do it by this method or by that method, and so you have to know what the method means for the first quiz. Usually by the time we take the test, I don't care which way you do it, usually. Okay? I'm going to just start with that example I gave you at the top. Y equals 2x minus 6, and y equals x minus 4. There's several different ways that you can handle substitution. One of them is if you've got one equation that's already solved for y and another equation that's already solved for y, you can simply set the 2 equations equal to each other. Okay, when does y1 equal y2? This is a form of substitution. So I would simply write down when does 2x minus 6 equal x minus 4. And that's a nice little easy algebra 1 equation. I'm not going to show all the steps on all the problems. I'll show it on this first one. And there's my answer, x equals 2. Nope, that's not my answer, that's half my answer. So you have to go back and get the rest of the answer, which means that you've got to get a y value. You want to take your x value and substitute it into the first equation. So y1 equals 2 times something minus 6, and then you take this number, the answer that you just got right here, and plug it in right there, and make sure that, or find out what you get from that. So y is equal to 4 minus 6, and y is equal to negative 2. There's the other half of the answer. X equals 2, y equals negative 2. And the final step is to check it in the second equation. This is going to be a required step. I'm going to expect to see something on your paper that evidences that you did that. And the easiest way to do that is just plug in both the x and the y. So in the place of the y, we're going to put negative 2. That came from right here. Equals, and in place of the x, we're going to put positive 2. That came from right here. And the rest of the equation was 4. This is y equals x minus 4 and substitute it. And you're just making sure that you have in fact got a true statement. That's your check. This means that your answer is correct, and you're going to write your answer in one of two ways, either sort of as a list, x equals 2, y equals negative 2, or as the point, 2 comma negative 2. Okay? For another one. We're going to want one that doesn't start out with both of the equations already solved for y. We're actually going to work this problem two different ways. Excuse me. At first, method number 1, solve them for y. Just rearrange both equations for y. You already know how to do that, and I'm going to do it fairly quickly. Sometimes you need to show a little bit more work than I do. I'm going to divide both sides by negative 1. So I get y equals 2x minus 5. That's my first y. That's going to be my y1. I'm going to go over to the other equation and do exactly the same thing. Pay attention to your positives and negatives. Divide both sides by 3. And there's my y2. I'm not thrilled because I got a fraction. That always causes me a little bit of trouble, but we can handle it if we just remember how all the stuff we learned back in September. Okay? So they're both solved for y, and now I'm going to say, where does y1 equal y2? Substitute this in, 2x minus 5, and substitute the other one in, negative 1/3 x plus 2. So that's the same process we did on the first example. There's absolutely no difference. The only thing is we got this fraction, which we never love, but we can get rid of the fraction if we want to by multiplying by 3. Don't forget your old techniques. I'm just going to multiply every term in the problem by 3. That gives me a 6, a 15, a negative x, and a 6, and now it's just not a problem. Okay, I'm going to skip a few steps here. This is algebra 1 level work. Add x to both sides, add 15 to both sides, and I get 7x equals 21. I'm going to divide both sides by 7, and I'm going to get x equals 3. I'm skipping a little bit of that grunt work there. There's the first step. All right, now you've got to go back and make sure that first you have to go back and find the y value. You can find the y value by plugging it into any convenient place. One convenient place would be right here, okay, or right here, or you could go back to the original problem here or here, any of those places. I probably would pick this one that hasn't got any fractions, and it's the easiest one I think to plug it into. So I would say that y is equal to 2 times, plug my x value in here, 2 times x minus 5, and that gives me that y is equal to 1. Now I did this with the first equation, and so I have to check it with the second equation. You have to make sure you've done it with both equations. And really, at this point, you should really go back and check it in the original equation, not in the rearranged one, just to make sure that you haven't made a mistake in your rearranging. So my original equation is this one up here. plug my x and my y into that and make sure that it comes out to be a true statement. So the original equation was x plus 3y equals 6. I'm going to take my x and my y and make sure that when I plug those two numbers in, I get a statement that is true. Okay? And the last thing to do is write your final answer, and the answer blank will be there for you, x equals 3, y equals 1, or write it as the point, 3, 1. So that's a perfectly good way to work the problem. People sometimes prefer to try to get through a problem without having fractions if possible. And sometimes you can do that, sometimes you can't. But let's see if we can look at working this problem a slightly different way and see what happens when you do it. It's the same problem. So I'm going to keep it problem number 2. And just look at an alternative form of substitution. All right, this equation here is pretty easy to solve for y. I negative 1 again. This is the same thing that I did in the other problem. But it was when I solved the other one that the fraction developed. So another option is if you recognize that you're going to get a fraction when you're solving for y, like you can kind of see it up here. You're going to have to divide by 3, and that's going to give you some fractions, at least one. What you can do instead is take this and substitute it in for y. I mean, after all, this says y is equal to 2x minus 5. So I can go over here where it says y, and in its place, I can put 2x minus 5. So x plus 3, and leave parentheses, 2x minus 5 equals 6. No fractions up here. This is very nice when you can do it like this. It just keeps those fractions out of the problem. It does require you to look ahead a little bit. Think about what you're about to do. Right? I'm going to go ahead and add that 15 to the other side, and I get exactly the same answer, x equals 3. And I didn't have to deal with any fractions, okay? You did need to finish as we did in the first problem by plugging it in and getting the y value and checking that y value in the other equation, okay? It doesn't matter if you solve for x or y. I'm not going to work this one all the way through, but if you see this equation over here, it would be pretty easy to solve for x. Just move the 3y to the other side, and then you could substitute that into the first equation. We've got some options about which way you can work these. Okay? All right, let's take a look at another one. Okay? So when I look at these two equations, I noticed that this one's going to be pretty easy to solve for y because there's no coefficient there. I won't have to divide, which means I'm not going to end up with any fractions if I solve for y. This one would be pretty easy to solve for x. Again, I'm not going to have to divide, so I'm not going to get any fractions. And it doesn't really matter which one of those things that you do. We're more comfortable solving for y, so I'm just going to go ahead and solve this one for y. Just get to divide by that negative 1. And because I notice that when I rearrange this equation, I can see that I'm going to have to divide by 4, and that's going to give me fractions. I'm going to choose not to do that. It would work if you did it. It would work, and I'm sure you could get the right answer. But I like to avoid fractions if I can. And so I'm going to take this, 3x minus 8, and I'm going to plug it right in there for the y. So x plus 4 times 3x minus 8 equals 7. And I don't have any fractions. Watch out for your arithmetic. Make sure you don't make any careless mistakes with addition, which is where I always mess up. I'm skipping a few steps here. And I get my favorite answer, x equals 3. Okay? X equals 3. Now I've got to figure out what y is. Again, you can plug that x in anywhere that's convenient. You can plug it in up here. You can plug it in here, but I think the easiest place is to plug it in right here. You're going to get the same answer. You should get the same answer any place that you plug it in. So pick the one that's the easiest. This is the first equation, and I'm going to get that y is equal to 3 times my x value, this one, x equals 3, and that gives me that y is equal to 9 minus 8 is 1. Okay? If I find the y value by plugging it into the first equation, then I'm going to do my check in the second equation. And always make sure that your final check is in the original equation, not the one that's been rearranged. Make sure you go back up to that original equation, x plus 4y equals 7. Plug in both the x and the y, and make sure that they both work. 3 plus 4 times 1 equals 7. 3 plus 4 equals 7. And we have a winner. Okay, so our solution is x equals 3, y equals 1 for the point 3, 1. Okay? If you rearranged it and got a fraction, just make sure you remember that you can multiply to get rid of that fraction. Okay? All right. Now this next example is the last one we're going to do here. X plus 4y equals 26, and x minus 5y equals negative 10. All right, when I look at both of these problems, I can see that I'm going to end up with fractions in both of them. Because if I solve this for y, I'm going to have to divide by 4. And that's going to give me 26 divided by 4. That's going to be a fraction. I'm going to have to divide by 5. And 10 divided by 5 is not going to be a fraction. But when I move that x over like this, when I divide by that negative 5 right there, I'm going to get a fraction on this side as well. And if I can avoid fractions, I usually will. If I can avoid them, but if I can't, then I learn how to deal with them. What I'm going to do now is say, instead of solving for y, let's look at what happens if I solve for x. Okay? So if I solve for x right here, I'm not going to have to divide. That means no fractions. If I solve for x here, I'm not going to have to divide. That means no fractions. That means it's probably going to be an easier path. Now you can solve one of them or both of them. I'm going to do this problem by solving both of them just because that's the way I work. In the first problem, I'd like you to see that example again. I'm going to solve this one for x. There's my first one. I'm going to solve the second one for x. Oops, that's not supposed to be an equals. Sorry. And instead of having y1 and y2, I'm going to have x1 and x2. And instead of saying y1 equals y2, I'm going to say x1 equals x2. This is a form of substitution. Solve them both for the same variable and then set them equal to each other. Now you've got a little bit of work to do to solve this equation. I'm going to skip a few steps. And when I solve it this way, instead of finding out what x is first, I find out what y is first. It doesn't make any difference as long as you make sure you know which one you're finding. Okay? I have found y. I now need to find x. So I usually take it to the first equation, and I usually use the easiest place. Where's the easiest place to plug in y? And it's going to be right there. Okay, into that one. So x is equal to negative 4 times 4. That's this 4 right here. Plus 26, which is negative 16 plus 26, and I get the answer x equals 10. Okay, so I have my two answers, x equals 10, y equals 4, and I've got one last thing to do. Run out of room. Scroll up a little bit. I need to go plug it into the second equation, and this is my final check. Let's go into the second equation, and make sure you go back and do it in the original second equation. That's the best place to final check your answers. I'm going to plug my x here, 10, my y, 4 from here, and make sure that I get the answer negative 10. Does 10 minus 20 equals negative 10? Yes. Okay, the single biggest mistake people make besides just basic careless arithmetic is they get this final answer and they've got x and y, and they write, they've got y and x, and they write the answer this way, and that's wrong. You need to write your ordered pair as x comma y, so that means you need to write the answer as 10 comma 4. Okay, so there are several examples for substitution. If you check in your textbook, you can find some additional examples. The problems that go along with these notes are on page 120 of your textbook, 13 through 16 and 18. Okay, and yes, just so you know, I do intend for you to skip number 17. Now, right now, you could stop the video and start working on these problems, and then you could restart the video when you finish that and learn the second method. So I am gonna go ahead and just add the notes for the second method right here. If you wanna pause, go ahead and do that. All right, the second method is called elimination, right? And it's pretty easy. It's not, I actually kind of like it a little bit better than substitution most of the time. When you do elimination, you tend to lay the problem out with one equation underneath the other. So I've got these two equations, and you also tend to do it when the problems are in standard form, or you put the problems in standard form in order to make it work out. Elimination basically says, can we either add these two equations or subtract them and cause one of the variables to disappear, okay? And in this case, I'm going to put parentheses around this whole thing. If I subtract x minus x, the x's are gone. 2y minus y leaves me with 1y, and 10 minus 6 leaves me with 4. There's my answer. Y is equal to 4. That's pretty easy. Okay? Once you get your first answer, you still have to get the second part of it. So we're going to go to the first equation. X plus 2y equals 10. The first equation. And I'm going to plug my y value in. I'll keep changing closest to equals. X plus 2 times 4 equals 10. And I have to solve a little bit here rather than just number crunch, but I get the answer x equals 2. I've got both answers now. And the last thing I have to do, as all of them, is I have to check it in the other equation. So check it in the second equation. The second equation is x plus y equals 6. Plug in your x, plug in your y, and make sure that you have a true state. This is called elimination. The biggest problem with elimination is that we tend to make mistakes when we subtract. And so one of the ways to get around that, or one of the ways to possibly avoid that, is to consider whether you could add and accomplish the same thing. And the answer is sometimes. Okay? So if you look at this, these two equations, can you see that if we add 4y plus negative 4y, that's going to be eliminated? So it'll give me 0. So instead of subtracting these two, I'm going to add them. 3 plus 1 gives me 4x. The y's are going to cancel out. And then negative 11 plus negative 9 gives me negative 20. Okay, finish solving, divide both sides by 4, and I get my first answer, x equals negative 5. All right? With every single one of these methods, whatever method we learn, once you find the first answer, you've got to go back and find the other ones. I'm going to go to the first equation, which was 3x, so 3 times negative 5, plus 4y equals 11, and you have to do some solving. Make sure that you don't make careless mistakes. My biggest problem, and I get the answer y equals 1. I have both answers, x equals 5, y equals 1, and the last thing I need to do is my check. You check in the other equation, the second equation, go to the original one, which is x, negative 5, minus 4 times y, which is 1, equals negative 9. Does negative 5 minus 4 equal negative 9? Yes, it does. Okay, so our two things that we're trying to, one of two things that we're trying to accomplish here is to have the coefficients of something, either the x, here, the x both has a coefficient of 1, and that led me to subtract, because 1 minus 1 is going to be eliminated, or, in this problem, where the coefficient is 4 and the other coefficient is negative 4, the opposite, and that led me to the decision to add in order to eliminate the variable. Right? Now, sometimes neither one of those things will work, at least not right away. So when you look at these two equations, you can see that if you add 2 plus 5, that's not going to be eliminated. And 3 plus negative 2 is not going to be eliminated. 2 minus 5 isn't going to be 0. And 3 minus negative 2 isn't going to be 0. None of these things will create the elimination process. So what we're going to do is we're going to transform these equations into new equivalent equations that we can use elimination on. All right, and I'm just gonna multiply by something on the top. I'm gonna multiply the top equation by 2, and I'm gonna multiply the bottom equation by 3. I'll do that without explanation. And let's see what happens, and then I think you'll see why I picked those two numbers. Okay, so I'm gonna multiply every single term in the problem by 2. 4x plus 6y equals 24. In the bottom one, I'm gonna multiply every single term by 3. 15x minus 6y equals 33. And what I've done is I've managed to get this and this to have the same coefficient, one positive, one negative. They are opposites. And that means I'm going to be able to add these two equations together. So the question is, how did I know what would do that? It's pretty simple. Basically, I want to make these two the same number. So I take the top equation here and multiply it by this. And I take the bottom equation and multiply it by that. And you just have to double check if you need to multiply by a negative to make the signs turn out the way that you want them to. We'll do one like that in a minute. All right, add both of these together. 19x, these go away. 24 plus 33 is 57. And divide both sides by 19, and x equals 3. Just a little note, if I hadn't said this earlier, you can use your calculator. It helps you get through the arithmetic of this. That's perfectly all right. Okay, now I still got to go back and find my y values. When you're doing this kind of elimination, go back to the very original problems to do this. It's usually the numbers are smaller. The numbers are smaller over here than they are over there, and you'll make fewer mistakes that way. So go to the first equation. 2 times x is 3, plus 3y equals 12. And again, you've got a little bit of solving to do here. And I get that y is equal to 2. Okay? Look at y is equal to 2. I now have both my answers. I still have the last thing to do. I've got to check it in the second equation. And always go back and check it in the original for this final check. 5 times 3 minus 2 times 2, and make sure that that's 11. 15 minus 4 is 11. That is correct. Okay, I'm going to take a look at that same problem. Exact same problem, but I'm going to make a different choice, just so you can see that there's lots of paths to right answers here. Okay? When I did it the first time, I chose to make these two the same. So I multiplied the top by 2, and I multiplied the bottom by 3. Okay? I like to make one positive and one negative. I think when I add, I make fewer mistakes than when I multiply, and when I subtract. So I like to make one positive and one negative. This time I'm going to decide to get rid of these right here. So I need this and this to have either the same coefficient or to have opposite coefficients. Both of them have the same number, one positive and one negative. So I'm going to take the top equation and I'm going to multiply by 5. I'll go ahead and do that just so you can see what that gives you. 10x plus 15y equals 60. And as I said, feel free to use your calculator to help you crunch the numbers. If I multiply the bottom by 2, I'm going to get 10x here. And I am telling you that you will make fewer mistakes if you can make this subtraction, instead of a subtraction problem, an addition problem, you will make fewer mistakes. So if I can make this a negative 10, I will make fewer mistakes, almost always. So instead of multiplying by 2, I'm going to multiply by negative 2, and that says 5 times negative 2 gives me negative 10. So now they have the same number with one positive and one negative. Okay, finish multiplying. Negative 2 times negative 2 is 4, and 11 times negative 2 is negative 22. And now I'm going to add. The 10 minus the 10 goes away. And 15y minus 4y. And that's just plus 4. 15y plus 4y is 19y. The most common mistake. Watch out for it. And 60 minus 22 is 38. Divide both sides by 19, and I get the same answer I got for y equals 2. When I worked at 4, I got x first, and I got y second. When I worked it this time, I'm going to get y first, and that means I got to go back to the first equation, and I've got to plug into the first equation. Make sure you don't plug in 2 for x. That 2 goes in for the y. And skipping a few steps, I get exactly the same answer. And you want to check it in the second equation, and I'm going to skip that step for right now just to save a little bit of time. Okay? So when I'm doing this, my favorite way to do it is to make the coefficients the same number, but one of them positive and one of them negative, and that way I get to add and I don't have to subtract. Okay, next on example 4. And if you haven't got your calculator out, you might want to get it out for this one, because this is going to have a few more fractions in it than we have had today. So 1/4 x plus y equals 7/2, and x plus 1/2 y equals 2. And you know, you can work this problem by trying to get the coefficients the same, but these fractions make us all kind of crazy. So the first thing I'm going to choose to do is get rid of the fractions. This has nothing to do with elimination. It just has to do with making you a little less anxious. So if I want to get rid of the fractions in the top equation, I need to multiply everything by 4. And if I want to get rid of the fractions in the bottom equations, I need to multiply everything by 2. This did not do anything towards getting, making the thing be able to do the elimination. It just fixed it so that I don't have fractions to deal with, okay? And now I'm going to treat this as if it were the original problem. You've got 2 options here. You can multiply the top equation by 2 or negative 2, and that will make the x's the same here. The x's would be the same. Or, if you want to make the y's the same, you can multiply the bottom equation by 4. And that's the one I'm going to choose to. So this one I'm not going to touch at all. Leave it alone. And this one I'm going to multiply times 4. And you can see that I have got the same coefficient, one positive, one negative. I'm going to be able to add 9x. That y's go away, equals 10, 20, 30. And 30 does not divide by 9, so 30 divided by 9 and reduce that fraction, and I'm going to get the answer 10/3. And this is why I mentioned getting the calculator out. Up until now, you could have done everything that we've done without your calculator. And in fact, you could do this without your calculator. It's just super annoying. So I'm going to let you use your calculator. If you have to check fractions, we're going to go back and put it in the original problem, all the way back up there. 1/4 times 10/3 plus y equals 7/2. So use your calculator effectively and efficiently to help you work this problem. I'm not doing this one in my head. I got out a calculator and I worked the problem, and I got y is equal to 8/3. Okay, you should certainly take a minute to double check that you get the same answer that I did. You can pause the video if you need to, and make sure that you are getting the same answer that I did. Okay. All right. After you get your second answer, you still have to do one last thing. This is the first equation. So the last thing you have to do is to check. This is required, it's not optional. You have to go to the second equation and double check that these two numbers, the 10/3 and the 8/3, work in the second equation. So I'm going to put in x, that's 10/3, minus 1/2 times y, which is 8/3, and I need to make sure that that equals 2. Again, grab your calculator, punch those buttons in your calculator, make sure that 10/3 minus 1/2 times 8/3, in fact, does equal 2. And then you know you have the right answer. This gives you a final answer here of 10/3, comma, 8/3. It's not our favorite problem in the world, but we can handle it, especially if we have a calculator. All right, the problems that go along with this are also on page 120 of your textbook. Problems 19 through 24. The odd answers are in the back of the book. The even answers you should still know if you have them right, because you're going to do all the checking that I told you to do. All right, that's, I think, about 11 problems for homework. I'll see you guys on Monday, Tuesday.